All right, welcome everybody. Today we're going to go ahead and start section 4.3. 4.3 is all about the division of polynomials, and we're going to talk about the first method today, which is long division of polynomials. If you're thinking to yourself, long division, didn't I learn that back in second or third grade? The answer is yes, and there are a lot of parallels between the process that you learned back in the day, which is called simple long division, and this harder polynomial division. So before we go ahead and do the harder polynomial division, let's go ahead and remind ourselves of all the different ways that we do simple long division. So let's say you were asked to divide 50 by 3. Hopefully you would remember the basics. You're going to go ahead and make a division bar. You would put the 50 inside and you would put the 3 outside. Then you would be asking yourself, how many times does 3 go into the first value, which would be 5? Hopefully you would conclude that that would be exactly once, which you'll write up top. Then multiply the 1 times the 3, which would be the 3, put it underneath the 5. Subtract 5 minus 3, that's going to give you 2. Bring down the remaining 0, and then try to go again. So 3 goes into 20. How many times? Well, that would be 6, which again goes up top. Multiply the 6 times 3. That's going to give you 18. Always subtract. 20 minus 18 is 2. At this point, 3 does not go into 2, which means if you wanted to continue the problem, you would have to add decimals. We could do that, but that's good enough to kind of get the idea. The fact that you get to a point in the problem where you can no longer put the 3 into the 2, that's how you know that the problem does not divide evenly. So 50 is not divisible by 3. There's going to be some extra, and you hopefully remember that that extra is called the remainder. Of all the different words, that's probably the easiest to remember is the remainder, but there are 3 other ones. So the answer that you get up top, the 16, we call that the quotient. Then the 3, which is the number outside, we call that the divisor. And then the value underneath the division bar, that is called the dividend. So quotient, dividend, divisor, and remainder, those are the 4 parts of simple long division, and those are also the 4 parts of polynomial long division. So we are going to be using those vocab words frequently, so make sure that you know what's what. Now that we've reminded ourselves about simple long division, let's go ahead and talk about polynomial long division. So if you're doing polynomial long division, you're dividing some polynomial f of x, so that's going to go up top. You're going to divide that by a non-zero polynomial d of x. That's going to go underneath. When you do that, you're going to go ahead and get some quotient, which we're going to call q of x. You're going to get some remainder, which we're going to call r of x. And then notice that r of x is over d of x, which is the divisor. That has to do with just the format of how you're going to give your answers. So you might kind of want to star that, circle it, highlight it. When I ask you to actually perform long division, this is the answer format that you're going to give me. So you just might want to make a note of that now so that you don't forget. Couple of other things to point out here. The degree of the remainder has to be less than the degree of the divisor. If you're lucky enough that the remainder is equal to 0, that means that the divisor goes evenly into the dividend. Also, the degree of the divisor has to be less than or equal to the degree of the dividend. And one way to kind of put all that together and perform polynomial, to perform division is by using the process of long division. So notice that for these next couple of examples, look at the directions. You're going to go ahead and divide using long division. And it is notable here that it says use long division. It's possible that in the near future, like next time, there's going to be a second way for you to do division. So you have to make sure that when it says long division, you know what that means. So for something like problem number 1 here, the first thing you want to notice is that your first value inside of the parentheses, this is what's going to be called your dividend. Then the second value in the parentheses, that's going to be your divisor. And again, the degree of the divisor should always be less than or equal to the dividend. So that checks out. What you're going to do is you're going to start this just like you did the problem up top. You're going to go ahead and draw a division bar. You are going to carefully put the dividend underneath. So x squared plus 3x minus 18. Make sure your division bar goes all the way across. And then you're going to put the divisor, x minus 3, on the outside. After you've written your problem, a couple things you want to ensure. You just want to ensure that nobody is missing. What I mean by that is that your divisor goes from a linear to a constant. Your dividend goes from a quadratic to a linear to a constant. You want to make sure that there are no missing terms, because if there are, we have to do an extra step. Second thing you might want to do here is you might want to remind yourself there's a 1 out front. This is x to the first. There's a 1 here, and there's x to the first. So some people are able to be fine without having all those 1s there, but if you think it would be beneficial, feel free to write them in. Just like in the previous simple division, you are always going to start with first into first. So you are trying to ask yourself, how many times does 1x go into 1x squared? Here's a better question to ask yourself. 1x times what would give you 1x squared? Whatever that missing value is, you're going to go ahead and put it up top. So 1x times what would give you 1x squared? Well, that would just be x. So you're going to go ahead and put that x up top. Then you're going to take that x and you're going to multiply it by each of the values in the divisor. So x times 1x is going to give you a 1x squared. And x times a negative 3 is going to give you a negative 3x. From here, you may or may not remember from above that you are always going to subtract. You have to subtract everything, all the terms. I have a little secret for that of how you do that. I like to say when you draw the line, you change the signs, which means that if it's a positive, you make it negative, and if it's a negative, you make it positive. That's just a way for you to remember that you're subtracting each one. Then you're going to go ahead and add up and down the columns. So a positive 1x squared minus a 1x squared, that will cancel out to be 0. A positive 3x times a positive 3x will give you a positive 6x. And then you're going to go ahead and bring down the negative 18. And now it's time for round 2. In order to do round 2, you're again always asking yourself first into first. So now you're trying to ask yourself 1x times what would give me 6x. So hopefully that very easily comes out to be a value of 6. So you're going to go ahead and put plus 6 up top. You're then going to multiply that 6 by each value of the divisor. So that's going to give you a positive 6x and a negative 18. Then again, remember my trick. When you draw the line, you change the signs. So positive 6x minus 6x cancels out to be 0. Negative 18 plus 18 cancels out to be 0, which means all you're left with is a 0. Remember, that is the remainder. Because of the fact that the remainder is 0, that means that the polynomial divides evenly, which means your answer is just the quotient. So your answer to this problem, how many times does x minus 3 go into x squared plus 3x minus 18? The answer is x plus 6 and x plus 6 only. So it's good that you show and do all that work, but you have to make sure you understand where the answer is. Let's go ahead and try another one. So take a look at number 2. Again, the first set of parentheses, that represents the dividend. The second parentheses represents the divisor. I'm going to go ahead and write that. So 3x minus 2 on the outside, 6x squared plus 2x plus 4 underneath. Go ahead and make that a little bit bigger. So again, if you think it would be helpful to add in this is to the first power, this is to the first power, some people find that necessary. If you're good without it, then by all means. Again, you're always going to start by doing first into first. So 3x times what would give you positive 6x squared. 3 times what is 6? 2. X times what is x squared? You need a 2x. Take that 2x, multiply it by each of the values in the divisor. So that's going to give you a 6x squared minus 4x. When you draw the line, you change the signs. Remember, that means subtract, subtract, subtract. The squareds cancel. 2x plus 4x is a 6x. Bring down the 4, and then it's time for round 2. When it comes to round 2, remember, first into first. So 3x times what gives you 6x? Hopefully you realize that's just a 2. 2 times 3x is a 6x. 2 times negative 2 is a negative 4. Draw the line, change the signs. The x's cancel. Careful, 4 plus 4 doesn't cancel. That actually becomes an 8. So the fact that 8 is your remainder, you can't go any farther because x's don't go into 8s. That's as far as you can go. And now for your answer, you have to write it in the format that was shown above. So again, the answer format, which is here, you have to write it as the quotient plus the remainder over the divisor. So your answer to this problem is the quotient, which is 2x plus 2, plus the remainder, which is 8, over the divisor, which is 3x minus 2. So maybe it looks a little bit funky, but that is how you have to give your final answer. Just so you're aware, remainders can literally be anything, positive, negative, 0, big, small, and they can even have variables. So no worries, whatever you happen to get for a remainder. Even though it's nice when the remainder is 0, it doesn't have to be that way. So hopefully you're catching on here, but let's do a couple more just to be sure, including some that have special cases. So I'm going to go here and set up my x plus 1 outside, my 2x cubed plus x squared minus 2x plus 3 underneath. Again, everybody is present. There's no missing terms. The more you do of these, hopefully the faster you get and the easier it is. We're going to go ahead and start by doing first into first. So x times what gives me 2x cubed. Hopefully 2x squared is what comes to mind. 2x squared times x gives me 2x cubed. 2x squared times 1 gives me 2x squared. Remember, draw the line, change the signs. The cubes are gone. A positive x squared minus 2x squared is negative 1x squared. And then notice when you bring down the leftovers, there's actually 2 things to bring down. So I'm going to bring them both down at once. That's just my personal preference. Now it's time for the next round. And again, in the next round, you're always going to be doing first into first. So positive x times what would give you negative 1x squared. Hopefully what comes to mind is negative x. So that's going to go up top. Negative x times x is negative 1x squared minus 1x. Remember, draw the line, change the signs. The squareds are gone. Negative 1x, bring down the 3. For the first time today, we're actually going to go and do a third round because x is equal to x. As long as you can put whatever the divisor is into what's in the remainder slot, you know that you're not quite finished. Again, first into first. So positive x times what gives you negative 1x. Hopefully what comes to mind would be a minus 1. So negative 1 times x is negative 1x. Negative 1 times 1 is negative 1. Draw the line, change the signs. The x's are gone, and you're left with a 4. That would, of course, be your remainder. So for your final answer, you're going to do the quotient, 2x squared minus x minus 1, plus the remainder, which is 4, over the divisor, which is x plus 1. Again, please make sure that when you do these problems, you actually do stop at some point and tell us what the answer is to make sure that you know you're writing it in the proper formation. Let's go ahead and do one more straightforward one, except now notice that in the divisor, you have more terms than you're used to. Instead of just having things that are linear, notice that you now have a quadratic. Perfectly fine for that to be the case. You're going to approach this the same exact way that you would any other problem. The work just might look a little bit different along the way. So I'm going to go ahead and start. X squared minus 5x minus 1 on the outside. 5x cubed minus 21x squared minus 25x minus 4 underneath. Again, notice nobody's missing. Everybody is accounted for. That's exactly what we want. So first into first. X squared times what gives you 5x cubed. That's going to give me a 5x. And again, just in case you like the colors, first into first, so that's a 5x. You're going to multiply that 5x by each of these values in the divisor, of which now there are 3. So 5x times x squared is going to give you 5x cubed. 5x times negative 5x is negative 25x squared. And then minus 5x. Then from here, when you draw the line, you change the signs. So the cubes are out. Careful, a negative 21x squared plus a 25x squared. That's going to give me a positive 4x squared minus a 20x, and then bring down the minus 4. Time to go again. And again, you're doing first into first. So x squared times what gives you 4x squared? Hopefully plus 4 is what comes to mind. Times x squared times negative 5x times negative 1. Draw the line, change the signs. Would you look at that? Everything cancels to be a nice remainder of 0. So if the question is how many times does this divide, then the answer is 5x plus 4. You could say plus 0 over the divisor, but when the remainder is 0, life is good, and you can just go ahead and disregard the remainder altogether. Now, hopefully after doing those 4 examples, you kind of understand what the process is. So on the back, we now just want to talk very briefly about some special cases. All the problems that we've done so far have been really nice because everything worked out perfectly. So what if it doesn't work out perfectly? So I would just go ahead and write myself the following note up top. Before dividing, make sure there are no missing terms. If there are, use 0 placeholders. That'll make a lot more sense in a minute when I show you what that means. But before you do your division, you have to make sure that nobody is missing. If the problem starts off as a cubic, you have to make sure that there's a cubic and then a quadratic and then a linear and a constant. If there's anything missing, you have to go ahead and use what we call a placeholder. Oops. So again, that's a 0 placeholder. So to kind of show you what that means, take a look at number 5. So 3x cubed plus 5x squared. Notice that it goes right from the square to the 9, which means you're missing the linear. Might not seem like a big deal now, but it is something you want to be really, really careful for when you go ahead and do your division. So 2x plus 3, no problems there. I'm going to write that outside just like usual. Here's the big difference. When I go ahead and copy my 6x cubed plus 5x squared, because of the fact that there is no x term, I'm going to go ahead and use a 0 placeholder, and I'm going to say plus 0x. Very, very important that you use that placeholder. If not, the rows and the columns are not going to line up nicely. So it takes no time at all to put that placeholder in, but it makes a big difference at the end of the day. Honestly, once I've got that placeholder in, it is business as usual. So 2x times what gives me 6x cubed? That would be 3x squared times 2x is 6x cubed plus 9x squared. Draw the line, change the signs, cubes are out. 5 minus 9 is negative 4x squared, and then bring down all your placeholders. First into first, 2x times what is negative 4x squared? That would be negative 2x. So negative 2x times 2x is negative 4x squared minus 6x. Draw the line, change the signs. The squares are out. 6x plus 9. So again, having that placeholder there just made sure that everybody added up all nicely. Final step here, 2x times what is 6x? That's going to be a positive 3. So that's going to give me a 6x plus 9. Draw the line. Change the signs. Everything cancels out to give me a remainder of 0. So if the question is how many times does this divide, your answer is going to be the quotient, 3x squared minus 2x plus 3. And again, because the remainder is 0, we're just going to go ahead and leave that out. One more long division problem here. And again, take a quick look. It goes from 4 to 3 to 2 to linear to constant. But the problem is in the divisor. Because the divisor goes from the square down to the constant, that means I need to use a placeholder outside. So I'm going to do x squared plus 0x plus 2, and then x to the fourth minus 3x cubed, and then so on. And again, once you realize why there needs to be a placeholder, it's really business as usual once you kind of get going. So first into first, x squared times what is x to the fourth? That's going to be x squared. Multiply to everybody in the divisor. So that's going to give me an x to the fourth. 0 times anything is a 0, in this case, x cubed plus 2x squared. Draw the line, change the signs. So the fourths are gone. Negative 3x cubed plus 2x squared minus 6x plus 3. That's round 1. Next round, first into first. So x squared times what is negative 3x cubed? That's negative 3x. That's going to give me negative 3x cubed, and then plus 0x squared, and then minus 6x. Draw the line, change the signs. The cubes are gone. That's going to give me a 2x squared. All the x's cancel, but I'm going to leave it as a 0x, again, as a placeholder. And now I'm ready for the final round. So final round, first into first, x squared times what gives you 2x squared? That would be plus 2. So that's going to give me a 2x squared plus 0x plus 4. Draw the line, change the signs. The squareds are out, the linears are out, and then 3 minus 4 is a negative 1. So your answer to this division is x squared minus 3x plus 2 plus negative 1 over x squared plus 2. And just so you're aware, if your remainder turns out to be negative, you can say plus a negative, or you can just say minus. So whether you do plus negative 1, or if you wanted to take out the minus and do 1 over x squared plus 2, those would both be completely identical in terms of how you would interpret them. So really it's up to you. So that's the bulk of today's lesson, which is all about long division. And then one final piece. What if instead of asking you to actually do the division, what if I had already done it and I asked you to put it back together to give me the original? The thing that allows you to do that is something called the division algorithm, and it shows you how the 4 pieces are related. So the 4 pieces are going to be related in the following way. The dividend, which is f of x, is going to be equal to the divisor times the quotient plus the remainder. Then they show you a little easy example here using just numbers, again, without using any variables. And again, this is kind of long division in reverse. Somebody already did the division, they found all the different pieces, and they just want you to put it back together. So for our final example, use the division algorithm to find the original problem if you're given the following. So d of x is the divisor, q of x is the quotient, and r of x is the remainder. According to the division algorithm, you're going to multiply the divisor, which is x plus 3, times the quotient, which is x squared minus 7x, and then you're going to add the remainder, which is 6. Hopefully you remember you have to use the magic word here, which is to FOIL. So as I FOIL, first is x cubed, outers negative 7x squared, inners positive 3x squared, last negative 21x, and then don't forget about the positive 6. If you simply combine all the like terms and put it in standard form, you're going to get that the original dividend was x to the third minus 4x squared minus 21x plus 6. Maybe a little bit easier than the other problems, but just as important. So thanks very much for tuning in to our long division lesson, guys, and we will catch you next time.